Alright guys, we're still looking at solving problems using Newton's second law of motion, but in this case we're going to focus on a slightly more advanced problem that takes advantage of the fact that Newton's second law says that the net force is equal to mass times acceleration. So let's look at the situation. We have a 3,000 kilogram elevator, accelerates upward at 1.2 meters per second squared. We're supposed to find the tension in the support cable. One thing I highly recommend when solving any problem, really ever, is to draw a diagram of it. So let's draw what this looks like. We have this elevator, and it has a mass of 3,000 kilograms, pretty hefty, freight elevator probably. And we have this support cable, and we have some force of tension in this cable that's upward. Now, let's stop and think for a second. Are there any other forces acting on this? And it turns out that there sure are. There's also the force of gravity. The weight of this elevator is pulling down on it. And what I can say is that the net force is equal to the tension force. Notice this has to be vectors here, plus the force due to gravity. And I'm trying to find the tension force, which means I need these other two parts. I need to find the net force, and I need to find the force due to gravity. And so all I do is I set about trying to find those. And let me go ahead and start our problem solving just like we always do. What are we given? We're given a mass, 3,000 kilograms. And I'm writing mass here. I suggest that as you start out, you write what that is. Hopefully, you're starting to see by this point that you can use the units to determine the type of quantity. This is kilograms. It means it must be a mass. They also tell us an acceleration, 1.2 meters per second squared. And now, what we want. And you can do this all in one piece, or you can piecewise it and go find the net force and then run another problem and find the force due to gravity. I'm going to do it as two separate pieces just to make it very clear what we're after. In this case, I'm going to go after the net force first. So I want to find F net, and in order to do this, well, this is just a Newton's second law problem. Force equals mass times acceleration. I know the mass, I know the acceleration, so the force is just equal to 3,000 times 1.2, and we calculator it up because, to be perfectly honest, it's still early in the morning. And so 36,000, or 3,600 it is, rather. So our net force will be 3,600 newtons. Sorry, had a pause in my brain there. Alright, so our net force is 3,600 newtons. Now we know that piece of the puzzle. We need to go out and get the other piece, the force due to gravity. So I'm going to list now a second want. What do I want now? I want the force due to gravity. And I need to think about how to find this. Of course, I already know. Weight is equal to mass times the acceleration due to gravity, 9.8. Notice that this really is just a form of Newton's second law of motion. We know the acceleration the Earth causes is 9.8. That times the mass is simply the force due to gravity. So in this case, my mass is 3,000 times 9.8. And so the weight of this thing will be this fairly large number, 3,000 times 9.8. Gives me a force of gravity of 29,400 newtons. So now I have my net force. Let me write that in so that we're not confused. That was shameful of me to have not done that. So we have our net force, and we have our weight, our force due to gravity. And now we're ready to plug this in, but we have to be very, very careful. Remember I said earlier, these are vectors. We need to choose a positive direction because these are in opposite directions. I personally like using up for the positive direction and down for the negative direction. So that's what I'll do. It's just as correct to say the other way around. It's really just what you prefer. Now, I know my net force is going to be upward. The reason I know this is that the elevator accelerates upward, and the net force is always in the same direction as the acceleration. So my net force is positive. So I can write that in. Just like I substitute in equations over here, I can substitute in that the net force is 3,600 equals, I don't know what my tension force is. I'm about to find out though. Plus my force due to gravity, but notice that gravitational force is in the negative direction, so it's plus negative 29,400. And now all I have to do is solve this equation for the tension force, and I end up with a tension force of 33,000 newtons. So notice what's happening here if I break this down afterwards, because you always want to think about, once you find your answer, is this answer plausible? Does it make sense? And so what we see is that there's a 33,000 newton force upward and a 29,400 newton force downward. Combining those gives us a leftover net force of 3,600 newtons. And then using Newton's second law of motion, it makes sense that everything checks out here. So always, always, always go back and apply common sense to your problem at the end. See if you got an absolutely ridiculous answer, because I could very easily see where you might look at this and think that that force looks awful big for the numbers involved here, but you have to stop and remind yourself of what all is going on. So there you go, kind of an intermediate problem involving Newton's second law of motion.